Hey guys, and welcome to week 3 of distance learning. Today we're going to continue on with probability, but we're going to look at them in a different setup. So we're going to look at them with the setup with tables. So probability with tables. But first, quick warm up about what we learned last week. So this says, find the indicated probabilities for each experiment listed below. So remember, an experiment is just what you're doing. So in this case, we're rolling a 7-sided dice. So a 7-sided die is rolled. The sides of the die have numbers 1 through 7 on them. So write the sample space. Sample space, remember, is just what could possibly happen. So what could possibly happen is that you roll a 1, a 2, a 3, a 4, a 5, a 6, or a 7. So those are the possible outcomes. That's our sample space. So what's the probability that we roll a 4? Well, there's only one 4 out of 7 possibilities. The probability of rolling a 4 is 1 out of 7, which equals a 14% chance of happening. What's the probability that we roll an odd number? So there's 1, 2, 3, 4 odd numbers out of 7 total. So the probability that we roll an odd is 4 out of 7, or 57% chance of happening. So you're more likely to roll an odd number than just the number 4. So the probability of rolling an even number, there's 1, 2, 3 even numbers out of 7. So you're less likely to roll an even than an odd. So the chances, or the probability, is 43% chance of happening. Probability that you roll a number that is less than 6, so that would be 1, 2, 3, 4, 5. That'd be 5 out of 7. So 5 divided by 7 is 71% chance of happening. Probability that you roll a number between 2 and 5. However, you don't include, you don't count 2 or 5 because this is less than, not less than or equal to, just less than. So numbers between 2 and 5 would be 3 and 4. So that's 2 out of 7. Which is 30% chance, well, not 30, 29% chance of happening. Okay, fun. Probability that you roll an 8. Well, the dice was 1 through 7. There is no 8. So that's 0 out of 7, which is a 0%, meaning that's an unlikely event. We talked about that before. If it's 100%, it's what we call a likely. If it's 0%, it's what we call an unlikely event. The next warm-up is about cards. So, find the indicated probabilities for each experiment listed below. A card is selected from a standard deck of playing cards, so there's 52 total things. I'm obviously not going to have you write out the sample space. That would be insane. So what's the probability of finding a 4? So there's 4 different suits in a deck of cards. There's hearts, spades, diamonds, if I can spell, and clubs. So hearts and diamonds are red, spades and clubs are black. So each one of these contains the numbers 2 through 10, and then a jack, a queen, a king, and an ace. So each one of these has 13 cards. So find the probability of a 4. So there was a 4 of hearts, there's a 4 of spades, there's a 4 of diamonds, there's a 4 of clubs. So there's 4 4s out of 52 total cards. So 4 divided by 52 would only be an 8% chance of happening. Okay, finding the probability that you pull a diamond. Well, there's 13 diamonds total because there's 2 through 10. And then there's a jack, a king, a queen, and an ace. So that would be 13 out of 52. 13 divided by 52 is going to be 25% chance of happening. Which makes sense because diamonds are 1 out of 4 different types. So 1/4 is 25%. Find the probability of, that you pull a 4 of diamonds. Well, there's only one 4 of diamonds. Yes, there's 4 fours. There's a 4 of hearts, a 4 of spades, a 4 of diamonds, and a 4 of clubs, but there's only one 4 of diamonds. So it'd be 1 out of 52. So 1 out of 52 is going to be only a 2% chance of happening that you're going to pull that card. Find the probability of an odd numbered card. So cards only have the numbers 2 through 10. So that's 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the probability that you're going to pick an odd number, there's 1, 2, 3, 4. So there's 4 different odd numbers. But each of those odd numbers is a heart, a spade, a diamond, and a club. So we said how many odd numbers? 1, 2, 3, 4. So 4 times 4, because there's 4 different suits, would be 16 out of 52. So 16 divided by 52 would be 31% chance. Okay, find the probability that you pull a black card. Well, half of the cards are black, half of the cards are red. So that's going to be 26, because 26 is half of 52, or a 50% chance. Right, now for the real stuff. So probabilities with tables. When calculating the probability using data given in a table, be careful, because the total number of outcomes might be the total for the entire table, or just the table from one row or column. If the event indicates you are choosing from a specific group, then only use the information in that column or row. So you got to really pay attention. What is the question asking me for? So here's our first table. It looks like, just looking at it before reading, we're comparing freshmen, sophomores, juniors, and seniors, and whether they're male or female. So a table summarizing the students in a classroom is given below. A student is chosen at random from this class. So in this particular classroom, there's freshmen, sophomores, juniors, and seniors. Freshmen, there's only 2 females, and then 6 males that are freshmen. For sophomore, there's 12 females and 4 males. For juniors, there's only 2 females, and there's no male juniors in the class. For seniors, there's 9 males and only 1 female. So the first thing I like to do is I like to go ahead and total everything up. So totals down here, you look at what's above. So 2 plus 12 plus 2 plus 1. So 12, so that would give us 17. And then for the males, so that means there's a total of 17 females in the classroom. And there's a total of 6 plus 4 plus 0 plus 9, a total of 19 males in the classroom, which that gives us a total of 36 total students in that classroom. So now let's total up how many freshmen there are. So 6 plus 2 is 8. There's 8 total freshmen. How many sophomores? 12 plus 4, 16. How many juniors? There's only 2 juniors. How many seniors? 10 seniors. So that's the way we read a table. So 17 here means there's 17 total females. 19 males, 19 males. Going left to right, this is freshmen, sophomores, juniors, seniors. This is the total amount of students combined. So that means we should get 36 by adding 17 and 19, and we should get 36 by adding these here. So let's check. 8 plus 16 plus 2 plus 10 equals 36. If they don't both come together to equal this 36, you did something wrong. So we need to find the probability of a senior. So we just go in and we point at a random person. What's the probability that it's a senior? So first off, there's 36 total kids in the class. Probability that it's a senior, there's a total of 10 of them. It doesn't matter if it's a female or a male. It just matters if it's a senior. So there's 10 total seniors out of 36 total students. So 10 divided by 36, we have a 28% chance that when we point at someone, they're a senior. Okay, now find the probability that they're a male. Again, it doesn't matter if it's a freshman, if it's a sophomore, if it's a junior, if it's a senior. We just care, is it a male? So we had 19 males out of 36 total students. So 19 out of 36, that's a 53% chance of happening. So we have a better probability of picking a male than picking a senior. Right, so this is where it gets a little more tricky. What is the probability that you pick a senior male? Okay, what is the probability that you get a senior male? So now we care that it's a senior and we care that it's a male. So there's still a total of 36 students. What's the probability that we pick a senior male? So seniors, there were 9 males. So only 9 out of 36. That's 25% chance of happening. Next one, find the probability, the senior from the group of males. So we're not looking at the total number of students. I'm looking at just the male students. So there were how many male students? There were 19 of them. Now, what's the probability from those 19 kids that I pick a senior? Well, how many of those kids are seniors? 9 of them are. So 9 out of 19, which is a 47% chance of happening, that I will pick a senior from just the males. Now, find the probability that I pick a male from the group of seniors. Okay, so this is a little bit different from the last one. This one I was picking a senior from the group of males, meaning I was looking at all the males. I put all the freshman men together, all the sophomore men, all the juniors, all the seniors. This one, I'm just looking at the seniors. I don't care about the freshmen and the sophomores and the juniors. I just care about the seniors. So how many seniors total are there? Well, there's 10 total seniors. And out of those 10 total seniors, what's the probability that I'm going to choose a male? Well, how many male seniors were there? There were 9. So I have a 9 out of 10 chances to pick a male senior from the group of seniors, which is a 90% chance I'm going to pick that male from this group of seniors. All right, I really wish I wouldn't have put this front and back, but here we are. So find the probability that you pick a sophomore. So again, talking about the total amount of kids. So there were 36 total kids. Find the probability that we're going to pick a sophomore. So there were 16 total sophomores. So 16 divided by 36 is going to give us a 44% chance of happening. All right, find the probability that you pick a female. So again, we're still looking at the total amount of 36. I'm going to have to flip back over. And there were 17 females. So that's 17 out of 36, which is a 47% chance of happening. All right, what was the probability of getting a male? 56 or 53. So you're more likely to pick a female. All right, find the probability that you pick a female that's also a sophomore. So still looking at the 36, but now we care that it's a female and she's a sophomore. So there were 12 of those. So I'm going to do 12 out of 36, which is a 33% chance of happening. All right, find the probability of female from the group of sophomores. So now I'm only looking at the sophomores. I don't care about anyone else. So there were 16 total sophomores. Now, how many of those sophomores are female? There's 12 of them. So 12 out of 16, which is a 75% chance. So you're more likely to pick a female out of the sophomores than a male. All right, find the probability that a sophomore from the group of females. Okay, so this is different. We're only looking at the females. So the total number of females there was 17 total females. Now, out of that 17 females, what's the probability that we pick a sophomore? And there were 12 sophomore females, so 12 divided by 17 is 71% chance of happening. So this one, we're just looking at the sophomores and picking a female. This one, we're looking at all females, doesn't matter what class they are, if they're a freshman, sophomore, junior, or senior. And what's the probability of picking a sophomore? Okay, so there is a difference. All right, next example. A table summarizing the students in this classroom based on the number of siblings they have and their favorite Marvel Avenger is given below. Oh, I can't do this one with you guys because we're not in class together. Didn't prepare for that. So yeah, so I guess I'm only doing one example with you. So it's super similar to what we were doing before. It's just your ability to be able to read it in table form. All right, I will upload the practice that goes with these notes. If you have any questions, please reach out to me, and I will talk to you all on Thursday. Have a great day.